Assalamualaikum and hello everyone. We are from Group 12 and we are going to present about IoT-based urban vertical farm. So this is our team members. I'm Madanan Berama Isham and Lu Wei Yang, Nur Nadia Binti Shamsuddin and Muhammad Afif Shazrin bin Shaful Anwar. So now I will let Nur Nadia to start our presentation.
IoT-based urban vertical farm is the cultivation of plants without using soil with the implementation of Internet of Things (IoT). And this IoT system will help the user to monitor the crops frequently. For the project scope, the user can set their desired pH for the plants, and the sensor will keep updated the data through the Blinks application. And the user will receive the notification if the water level is low and when the pH is minimum or higher than the desired input. For the market value, this product is easy to use and provide a complete and suitable system where plants can grow while providing minimum supervision. And it is also cheaper than other available products with complete IoT features. And it is also suitable for people who have less access to land area to grow the vegetables. For the problem statement, increasing of world population, more mouth to feed. According to the United Nations, the current world population of 7.3 billion is expected to reach 8.5 billion by 2030, means more mouths to feed in the future. Next, wastage of water increases with the increase of land area. Based on research from Asian Journal of Advances in Agricultural Research in 2020, it is shown that the increasing land area, water sources also increase. The objective of this project are we want to develop an application in which the user can monitor their food crops frequently. Next, to build a system in which the user can set up the pH value preferred by them. And finally, to develop a system that can measure accurately to maintain an optimal pH all the time.
Assalamualaikum. My name is Muhammad Afif Shazrin bin Shaful Anwar. So I will discuss about our NABC concept and survey form. So for NABC concept, first is based on the research from problem statement. What we expect is the wastage of water increase with the increasing of land area. So we need enough space or land to cultivate our crops. Next is how to create a controllable nutrients, pH and intensity of light. So number 2 is approach. How we able to meet the requirement for our product. So we use multiple IoT, which is the pH regulator, intensity of light monitor and also a water level detection sensor. Third is our competition. Mainly, our rival also came from having vertical farm system with IoT and automatic features. Many companies have been working on hydroponic system widely. And lastly, the benefit of our product. We able to ease the customer to monitor the pH of nutrient, water level and light intensity by sending it to their phone, mobile phone. So next is our survey form. Our respondent is around 103 responses, mainly aged around 19 to 24 years. The race is Malay around 80%, Chinese 12.6 and the other is Indian. So next is most of them already heard about hydroponic farm system around 84.5%. And do they think that traditional farming will increase the water consumption? Majority of them say yes, around 80%. And they agree that the food consumption around the world will increase every year. 93.2% agree with that. So next is they agree that most of them agree the soil-based agriculture will affect the quality of water around 68.9%. And next is the efficiency of plants growth is important to them. 100% of them say yes. So next is did they know that the pH level and the amount of nutrient will affect the plant growth? Most of them say yes. And also most of them think that if there is a system, what do they think if there is a system that user can check the water temperature and pH level just using their phone? Most of them say convenient, around 97.1%. And next, around 76.7% say that the temperature of water play a big role in the plant's growth. And lastly, it is convenient for user if they can get the notification if the intensity of light for their plants are not enough through their phone. Around 95.1% of them say yes. So that's all from me. Thank you.
Greetings to total and everyone. I'm Liwei and I will continue the presentation with the flowchart of this project. So this is the flowchart for page setting with phone. So for information, we are using 5 boxes. Box A is for the mixture of nutrient, box B is for the IoT, box C is for the alkali nutrient, box D is for the acid nutrient, and box C is for the water. So we'll go to with the box A first. So after the user set the pH value by using the phone, so we will test the water level of in the box A. So if the water is not enough, so we will pump the water from box C inside to box A. And then we also will detect the pH value of solution in the box A, the mixture of nutrient. So if the detect value is not within the range of the setting value, so the system will adjust it by adding the alkali or the acid nutrient. So for next one is for the automation going LED light up. So we will sense the intensity of light surrounding of the structure of the system. So if the surrounding is bright, so it will light off. However, if the surrounding is dark. And now is for the block diagram. So there are 3 sensors as the input: ultrasonic sensor, LDR sensor, and pH sensor. And for the processor, there are 2 parts: Arduino Uno and ESP32. And for the output, we have the water pump and the LED glow light strip. And the user can set the pH value by using the phone. So for the component specification, so for the Arduino Uno, so it is a microcontroller that can control the output based on the situation of the different input. So in the easy word, so it is a control switch to on or off and device based on different input. So for the ESP32 node MCU, so it is a MCU with integrated Wi-Fi and Bluetooth connectivity, and we use it to connect the phone with Wi-Fi. And the user can set and observe the change of pH by using the phone. Then it also can send the notification to the user. So these 3 parts is for the sensor part. So first one is ultrasonic sensor, so it will detect the water level. Second is for the pH sensor, it will detect the pH, and the LDR sensor will detect the brightness of surrounding. So for the software specification, Bing apps is used in this project. So 4 widgets I decide to use. So for the slider, the user can set the pH solution, and for the eventer, the user can set the timer for watering the plant, and the value display is real-time monitoring the pH. And for the email, it can send a notification to the user by using the email. So now it's for the simulation part. So first one is for the automation going LED light up. So the LED will light when the surrounding is dark. So for next one is for the water level detection. So the cover of the calculator is illustrate the water level of the solution, and the ultrasonic will detect the distance. So if it is far away from the ultrasonic, so the water pump will on. And if the water level is near, so the water pump will be off. So for the next one is for the pH setting with phone. So the solution I use here is water, and the pH sensor is inside the water. And then this is the Bing apps. So we can see that the pH value is about 6 point something, and here within the range that I set, 6 point something. And then I will lower down the setting value. So if the detect value is not within with the setting value, the water pump will be on. So just now I have increased the pH setting, so but it also not within the pH setting, so the another water pump will be on. So if the setting value is within with the range of the detect pH, so both the water pump will be off. So that's all for me. Thank you.
Okay, so now I will continue our presentation with the project demonstration. But before that, I will briefly explain about the main parts of the project prototype. Okay. The first box is the IoT box, where we store our main components. Second box is the total solution box. The third box is the pure water box, where we store pure water. The fourth box is base solution box, where we store the base solution for the plants. And the last box is acid solution box, where we store acid solution for the plants. Three solutions, which are pure water solution, base solution, and acid solution, will be pumped to the total solution box. And the mixture of solution from the total solution box will be pumped to the three pipes that contain our plants. Project demonstration. Firstly, the user can set the timer for watering the plants at the inventor on the Blink app. When the time is set, the system will water the plant. These are the three solutions that I said earlier. It will pump the solutions to the total solution box, and the pH of the mixture will be monitored by the pH probe. The mixture of the solutions from the total solution box will be pumped to these three pipes that contain the plants. For this prototype, we use lettuce seed, and the solution residue will be flowed back to the total solution box, and the mixture will be recycled back. And for this prototype, we use LED grow light. Now for water monitoring. The user can monitor the level of acid, base, or pure water solution just by using their phone. When the level of acid, base, and pure water solution is below the level of what we set on the coding, it will notify the user via email. Now let me show you how the system will notify the user via email. This is for acid solution. It will notify the user via email. And this is for base solution. When the solution is below the level of what we set on the coding or empty, it will notify the user. And this is for pure water solution. When the solution is empty or low, it will notify the user via email also. So now for pH monitoring. The user can set up the pH of the total solution just by using the slider on the Blink app. For this project, we use lettuce seed. So its optimum pH for it to grow is 5.8. So the pH probe will monitor the pH of the total solution. Now for the water pump. The water pump will only pump water to the total solution box if the level of the total solution is below than the level of what we set on the coding. If the level of the total solution is above the level of what we set on the coding, it will stop pump water to the total solution box. Potential errors identification. Firstly, when the USB cable of Arduino is unplugged from the computer, the relay of water pump of acid and base are not functioning properly. The pH value detected is always fluctuated. And for the potential solutions, firstly, for the crashing of cloud of Blink apps, the USB cable will always connected to Arduino in order for the pH value can be stored and the nutrient can be added properly. The other solution is that the timer is set in the coding for detecting the pH value. As the timer is set, the data sent will reduce within 1 second, and the cloud of Blink apps will not crash. The last one is a timer is set in the coding. As the timer is reached, there are more time for solution to mix properly, and pH value of solution may always constant before pH sensor detected the solution. So that's all from us. Thank you for watching.